Good evening all. Is the video and audio clear? Say. Yeah. So before going to start today's session, can you tell any doubts with regard to the previous one? To any of you? Any doubts for anybody? All right. So let us start with the problem. Find the point on x-axis which is equidistant from the points 2, -1, -4 and -4, 3, 10. So this is one of the simple problems. So can you tell the approach? So let us take that the required point is say P of the coordinates x, y, z, or you can take it as x1, y1, z1. So if you take that, the given points are A and B. It is given that the point is equidistant from A and also from B. So you can say that PA is equal to PB. Accepted? So you can take squaring on both sides. So you have PA square is equal to PB square. Since the point P is lying on x-axis, its y coordinate as well as z coordinates are 0. So you have y1 equal to 0 as well as z1 equal to 0. So if you apply the distance formula, then you have x1 minus 2 whole square plus accepted. So you can simplify the equation and you will get the result. So the required point, if you calculate, it will come as so I am leaving the simplification to your turn. Is that required for you to do the simplification? You please take a note of that. After noting, please tell. So the next problem is, if a plane meets the axis in capital ABC and centroid of triangle ABC is PQR, then show that the equation of the plane is x by p plus y by q plus z by r equals to 3. So please take a note of the question, right? So as per the problem, let us consider the 3D system, x-axis, y-axis, z-axis with origin. It is given that the plane meets the axis at 3 points. This is capital A, this is capital B, and this is capital C. So where the plane meets x-axis at the point A, y-axis at B, and z-axis at C respectively. So as we know, let us take the points as A 0 0, 0 B 0, and 0 0 C. So these are nothing but the intercepts made by the plane on coordinate axis. So obviously the equation of the plane consisting of these 3 points in writing the intercept form is x by a plus y by b plus z by c equal to 1. Accepted all? Any doubts? Now, since we have 3 points, you can frame the triangle. This is triangle ABC. Now, for every triangle, we have a centroid. Let us calculate the centroid for triangle ABC. So, as per centroid formula, its value is a plus 0 plus 0 by 3, 0 plus b plus 0 by 3, and 0 plus 0 plus c by 3. Accepted? Using the centroid formula. I think everyone will know the formula of centroid. So it is nothing but a by 3, b by 3, and c by 3. But actually, from the problem, it is given that the centroid of triangle ABC is PQR. So if you equate that, the value is equal to PQR. Equating the respective values, we will get that A is equal to 3P, B is equal to 3Q, and C is equal to 3R. Agreed? Any questions? So let us substitute the values of ABC in the plane equation. So you have x by 3P plus y by 3Q plus z by 3R is equal to 1, which gives that x by P plus y by Q plus z by R equals to 3, which is our solution. So please take a note of that. If you have any other queries, you can ask. After noting, please tell. Right? So do you know what is meant by a variable plane? Say. So let us feel that the plane moving in the space, we call it as a variable plane. Okay? It is moving in the space. Now let us focus some of the problems on this one. A variable plane is at a constant distance (3p) from origin. And makes intercepts on axis. Show that the locus of centroid of triangle ABC is x power minus 2 plus y power minus 2 plus z power minus 2 equals to p power minus 2. Okay? So please take a note of the problem. Let us discuss now. So a variable plane is nothing but a plane is moving in the space and it is meeting or intersecting the coordinate axis at the points capital A, capital B and capital C. It means that it meets x-axis at A, y-axis at B and z-axis at C. Then we have to show that the centroid of triangle ABC satisfies the equation this one. Clear to all? The question tag of the problem. Right? Now let us take that centroid is x1, y1, z1. The centroid of triangle ABC, let us take that it is x1, y1, z1. As usual, if you consider the 3D system, you have three intercepts A, B and C. And we take the regular coordinates, the intercept values as A00, 0B0 and 00C. So the equation of the plane containing the 3 points, the intercept points, is nothing but x by A plus y by B plus z by C equal to 1. This is our plane equation. So you can also write this equation as so here variable plane means we are going to understand that it is moving in the space, while moving it is intersecting the axis. In such way we need to understand. So while moving in the space, it is intersecting the axis. Hence, we are getting the intercepts so that you will get a triangle. Clear? Right. So did you agree with that equation? Equation 1? Any doubts? Fine. Now, as usual, let us calculate the centroid of this triangle. So it is nothing but a by 3, b by 3 and c by 3. Initially, we have taken that centroid is x1, y1, z1. So if you equate this value to x1, y1 and z1, this gives that a is equal to 3x1, b is equal to 3y1 and c is equal to 3z1. That was the thing. So if you look at the problem, he mentioned about the centroid. So you have calculated from the centroid formula what is the value of ABC. It is mentioned that it is making intercepts on the coordinate axis while moving in the space. So we have written the plane equation, and equation 1 gives the equation of the plane in intercept form. There is one more thing given in the problem, that the plane is at a distance 3p from the origin. So if you assume that this triangle as a plane, this plane is above 3p distance from the origin. So you know the plane equation and you know the point origin. If you apply the distance formula from point to the plane, it is nothing but 3p. Clear? So if you apply the distance formula, the formula of distance is equal to modulus of ax1 plus by1 plus cz1 plus d by square root of a square plus b square plus c square. This is the distance formula we mentioned. So here distance in the problem is given that it is 3p. x1, y1, z1 is nothing but the point from which we are calculating the distance. So it is nothing but 0, 0, 0. And ABCD values are nothing but the coefficients of the plane what you have written. D stands for the constant, ABC value stands for x, y and z coefficients respectively. So since this is our plane equation, substituting the values here, it is nothing but modulus of 1 by a into 0 plus 1 by b into 0 plus 1 by c into 0 minus 1 whole divided by square root of 1 by a square plus 1 by b square plus 1 by c square. So any questions on this to anyone? Or is that clear? Right. Now, since these values are 0, 1 will remain in the numerator by applying the modulus. So taking reciprocal on both sides and taking squaring on both sides, we will have 1 by a square plus 1 by b square plus 1 by c square is equal to 1 by 9p square. So if you substitute the values of ABC, A is nothing but 3x1, B 3y1 and C 3z1 here, 9 gets cancelled. So you will get the value as 1 by x1 square plus 1 by y1 square plus 1 by z1 square is equal to 1 by p square. So from that, the locus is nothing but x power minus 2 plus y power minus 2 plus z power minus 2 equal to p power minus 2. Okay? So please take a note of that. If you have any other queries, you can ask. So can I erase this? Please tell. Fine. So similar kind of question is also given that. So I will give it as a assignment for you, very simple. A variable plane is at a constant distance. You take it as P. Apart from 3P, you take it as P from origin and makes intercepts ABC on axis. Show that locus of centroid of triangle ABC is given by. You take 9 here. 9 p power minus 2 you will get. Okay? So this problem, you take it as an assignment. Same model, same steps. So in the distance, apart from 3p, you will take p, the solution will come automatically. Clear to everyone? If you are clear, I will go with the other one. Because problems on variable are very similar. Variable plane. Have you noted the problem? Right. The next problem is also very similar. The problem is a variable plane is at a constant distance p from the origin and makes intercepts ABC on axis. Show that the locus of, here I want to change a small thing, the locus of centroid of tetrahedron OABC is, I want to change like this. Sure, later I want to increase the difficulty of the problems because as per my view, some of the students have the knowledge prior to the class sessions with regard to solid geometry, and some of you are learning for the first time. So I need to cover the both things. So initially I will go with the basic level, then I will go with the top level. So I want to cover some of the UPSC previous year questions. So that is enough, the maximum level you can expect with regard to the class sessions. Right. So planes is a easiest one. So the difficulty is nominal compared to planes. If you go with the straight lines and spheres, there you can expect the difficulty. Don't feel that difficulty is somewhat very big. The only thing is, while you are doing problems with the numbers 1, 2, 3, 4, in difficulty you will do the problems with x, y, z. That is the only difficulty. Let me say, while writing the plane equation, you are saying it is 2x plus 3y plus 4z equal to 0. So if you talk of difficulty, apart from 2, 3, 4 numbers, I will write it as alpha x plus beta y plus gamma z. So concept is similar and calculation part takes a little more. That is the only thing compared to difficulty. Clear? Yes. So may I know how many have the definition of centroid and formula for calculating the centroid of tetrahedron? So how the tetrahedron forms and what is the formula for centroid of tetrahedron. Anybody has any doubt? If so, let me give a small thought of it. Right? So, you simply take a triangle. So, for this triangle, if you take any other vertex, adding each of the three to this one, you will get the tetrahedron. So, how the tetrahedron forms is that one. Another thing is, since it contains the four vertices, it will have the four faces. So, the formula for centroid of tetrahedron is x1 plus x2 plus x3 plus x4 by 4 for x coordinate. Similarly, y1 plus y2 plus y3 plus y4 by 4 and for z also. So, if you are taking 3 vertices, by 3. If you are taking 4 vertices, by 4. There is the difference. Okay. So, the pattern or solution of the problem is very similar to the previous one. So, take that this is the plane equation I have considered. So, here you are taking the tetrahedron as OABC. So, for O, vertices are 0, 0, 0. For A, it is x-intercept, A0, 0 is the point, B, y-intercept, 0, B, 0 is the point, and C, z-intercept, 0, 0, C is the point. So, as usual, take centroid is equal to x1, y1, z1, consider the intercepts as it is, and this is our plane equation. And then, if you apply centroid formula here, A by 4, B by 4 and C by 4. Adding all the first coordinates by 4, adding all the second coordinates by 4, and adding all the third coordinates by 4. This is the centroid of tetrahedron OABC. So, equating this value to x1, y1, z1, we get that A is equal to 4x1, B is equal to 4y1, and C is equal to 4z1. Again, we apply the distance formula. It is given that distance is nothing but p. This is the equation what we will get here. Right? Substituting ABC values, you will get the required solution like this. This was the approach. So, previous problems and the current problem both have the same approach. Okay? Is it clear for everyone? If anybody has any doubts, you please ask. Yes or no? So, is everyone following this, or do you have any confusion? Okay. So, I want to take the other models. So, the basic level of problems on planes will be in this module. Now, let us introduce a new concept, that what we will get from the intersection of planes. Let me say I have considered two planes, pi 1 and pi 2. If they both intersect, what is the respective geometric shape? As we know, this is one line, say L1, this is another line, say L2. If both lines intersect, the intersection is nothing but a point. The geometric thing is nothing but a point is common to both the lines. Similarly, if two planes intersect, what is the common part for both of them? The intersection. Can you specify? right? So intersection is nothing but a line. So if you want to take a small visualization, let us consider our room. So you take the corner of the room. So if you imagine that this is the corner line, so this corner line is surrounded by one wall on one side and another wall on this side. So each wall is nothing but a plane, and two planes will merge like this, and this part is nothing but in the form of a line, the straight line. So far you have studied many definitions with regard to straight line. What is a straight line, how it forms, how to reduce its equation, etc., etc. Here onwards we change our perception as straight line is nothing but the intersection part of two planes. In other words, the intersection of two planes gives us a line, that is actually we are calling it as a straight line. Okay? So the definition of straight line, newly termed as the intersection of two planes. Clear to everyone? Right. So if you visualize, you consider the 3D system in a simple manner. So this is XY plane and this is XZ plane. The common part is X-axis, which is nothing but a line. Clear? So always the intersection of two planes is nothing but a line, that is we are calling it as a straight line. Now the concept here is, whenever two planes intersect, from that line of intersection we want to calculate another new plane. So we want to calculate a plane which passes through the line of intersection of two intersecting planes. So for that, the formula is very simple. So let us take that pi 1 and pi 2 are nothing but two intersecting planes. So the equation of a new plane which passes through this intersection is pi 1 plus lambda pi 2 equal to 0. So please take a note of that formula, where lambda is a indeterminate. The value we need to find depending upon the problem. So from the specific condition satisfied by the new plane, we are going to obtain the value of lambda. So lambda value varies from problem to problem and condition to condition. So how the formula pi 1 plus lambda pi 2 equal to 0 comes, we are not discussing on it. Our aim is mainly concerned with the logic, the formula and problem evaluation techniques. Clear? After noting that formula, you please tell, I will take the problems. Right. Pi 1 plus lambda pi 2 equal to 0 gives a new plane which passes through the intersection of pi 1 and pi 2. So this is a condition to calculate a new plane equation. That new plane passes through the intersection of pi 1 and pi 2, which is nothing but a line. Clear? So if you fulfill the condition, you are going to get a first degree equation in XYZ. You are getting a new plane equation. So very simple it is. Just hold anything. Let us take this book. This is a plane. This is another plane. This corner is nothing but a line. Accepted? Right. Now, this is the new plane I am passing to like this. This passes through the line of intersection. That you can visualize. So, in other thing, in our olden days, there is a cross table which we use to read books. Yes, lambda can take 0, any positive value, anything you can take. That's why I said lambda is a indeterminate based on the problem condition. That's it. So, if you take that a book reading thing, a book reading table in olden days, it is of this X shape, right? On this, the book will be placed. Can you imagine that shape? A wooden thing made in the shape of cross, so that the books will be placed on that and will be read very comfortably. Right? So, at this point, you have the line of intersection. You place a new plank here. That you can call it as the plane passing through the intersection of these things. It means if you can take two cardboard papers, you attach them through a fevistick, and you put any plane at that intersection place. That's it. The new plane you are taking. So the new plane will be parallel to one of the planes, perpendicular to them, and exactly bisecting the angle between the planes, etc., etc. Anything you can take. So the new plane varies from condition to condition. Clear? So any more doubts for anybody? Right. If anybody has any problem with regard to the visualize the concept, you please let me know. So all of you are clear about this formula, pi 1 plus lambda pi t equal to 0, what it gives actually to us? Right. Now let us start with the problem. So find the equation of the plane passing through the line of intersection of x plus y minus z minus 6 equal to 0, comma, two x minus 4y plus 3z plus 5 equal to 0, and passing through the point one one one. So please take a note of the problem. We will discuss that. Is it noted? So if you take that the first plane is pi 1, the second plane is pi 2, our required plane is passing through the intersection of these two planes. So the formula is pi 1 plus lambda pi 2 equal to 0. So you have x plus y minus z minus 6 plus lambda into 2x minus 4y plus 3z plus 5 equal to 0. Now I want to determine the value of lambda as per the problem condition. It is given that the new plane passes through the point 1, 1, 1. It means that if you feel that it is our required plane, it contains the point 1, 1, 1. So obviously 1, 1, 1 satisfies the plane equation. So let us substitute 1, 1, 1 in place of x, y, z here and give me the value of lambda. So is it 5 by 6? Please check everyone. So lambda will be 5 by 6 if you substitute 1, 1, 1 there. So substituting lambda value here, you can simplify the plane equation. So you are going to get it as 16x minus 14y plus 9z minus 11 equal to 0. So please check on that. Accepted? That is our solution. Now you can feel the difference that this formula will be used and we are determining lambda with respect to the problem condition. Clear? So can I take the other model? Right. So find the equation of the plane passing through the line of intersection of x plus y plus z minus 1 equal to 0 and 2x plus 3y plus 4z minus 5 equal to 0 and perpendicular to the plane x minus y plus z equal to 0. Please take a note of this model. After noting, please inform. Is it noted? So let us apply the formula first. So you have x plus y plus z minus 1 plus lambda into 2x plus 3y plus 4z minus 5 equal to 0. Now let us take the coefficients as common, which gives that 1 plus 2 lambda into x plus 1 plus 3 lambda into y plus 1 plus 4 lambda into z minus 1 minus 5 lambda equal to 0. Right? So let us say that this is our required plane, and it is given that this plane is perpendicular to the given plane. This is our given plane. So here the xyz coefficients are nothing but whenever you draw a perpendicular to the required plane, the normal drs. And similarly, for the given plane, if you consider the normal, its drs are nothing but the coefficients 1, minus 1, 1. Since the two planes are perpendicular, their normals are perpendicular, so the drs of the normals satisfies the condition a1, a2 plus b1, b2 plus c1, c2 is equal to 0. Applying this formula to their coefficients, you have 1 plus 2 lambda into 1 plus 1 plus 3 lambda into minus 1 plus 1 plus 4 lambda into 1 equal to 0. So I will leave the simplification to your part. So if you simplify, you will get lambda is equal to minus 1 by 3. Substituting lambda value in the equation 1, I think you will get the equation as, say, x minus z plus 2 equal to 0. Can you check? X minus z plus 2 equal to 0. That was the required plane equation. Clear to everyone? X minus z plus 2 equal to 0 is the required equation. Yes. If anybody has any doubts with regard to this problem, you can ask. So all of you are clear with this model? Yeah. Here please understand that whenever you write the plane equation, the coefficients of x, y, z are nothing but the drs of the normal to that plane. So just imagine that you have taken a wooden plank and you fixed a rod to it, the iron rod. So the rod is perpendicular to the very plane. So the drs of this normal are nothing but xyz coefficients of the plane. Right? So this is our plane. Its coefficients are 1, minus 1, 1. So drs are nothing but 1, minus 1, 1. And for this plane also, you will take the xyz coefficients. Clear? Right. So if you want to get a visualization, you take a wooden plank, fix iron rod. You take another wooden plank, fix iron rod. Now you place that two planks are perpendicular. Automatically, the two rods will be perpendicular like this. Clear? The visualization. So hence, for the normal drs, we will apply the perpendicularity condition. So whenever two planes are perpendicular, by default we need to understand that their normals are perpendicular. So we apply the perpendicularity condition to the drs of their normals. Okay? Right. Any other questions from anybody? Please tell. Right. So I will take the other model. So this is also very similar, but there is a little variation here. So the problem is, find the equation of the planes. Find the equation of the planes passing through the line of intersection of 2x plus y plus 3z minus 2 equal to 0 and x minus y plus z plus 4 equal to 0 and each plane is at a distance two units from origin. Each plane is at a distance 2 units from origin. Okay? Please take a note of this model. So is the question tag clear? What is to be done? So can I continue? Yeah. So first of all, let us apply pi 1 plus lambda pi t equal to 0 here. So you have 2x plus y plus 3z minus 2 plus lambda into x minus y plus z plus 4 equal to 0. So taking x, y, z values as taking common x, y, z coefficients, you have 2 plus lambda into x plus 1 minus lambda into y plus 3 plus lambda into z minus 2 plus 4 lambda equal to 0. So here we need to understand that this plane has a property that if you calculate the distance of that plane from origin, its value is 2 units. So if you apply the distance formula, so here x1, y1, z1 are nothing but 0, 0, 0. ABCD values are nothing but the coefficients 2 plus lambda, 1 minus lambda, 3 plus lambda. Right? So let us apply the value there. So you have 2 is equal to modulus of 0 plus 0 plus 0. D value is minus 2 plus 4 lambda by square root of 2 plus lambda whole square plus 1 minus lambda whole square plus 3 plus lambda whole square. So we can do squaring on both sides, and we can take reciprocal also on both sides. Or there is no need to take the reciprocal. Take this value to the left hand side and do squaring on both sides. You will get that 4 into 2 plus lambda whole square plus 1 minus lambda whole square plus 3 plus lambda whole square is equal to 4 lambda minus 2 whole square. So if you simplify this equation, you are going to get it as lambda square minus 12 lambda minus 13 equals to 0. I hope so. Everyone will get the same equation. So if you factorize this, you will get that lambda equal to minus 1 comma 13. So could you check on that, please? Since we have two lambda values, you are going to get two plane equations. So here we can say that if you fix that this is origin O, from this origin you are calculating two plane equations whose distance is here 2 units and here 2 units. This is the visualization of the problem, right? So by substituting the respective lambda values, you will get the solution as x plus 2y plus 2z minus 6 equal to 0 is one plane equation. Another one, 15x minus 12y plus 16z plus 50 equal to 0 is the other one. Okay? After noting, you please tell. So anybody has any other doubts over this problem? Or is the approach clear? So do you agree with the answer given there? Any questions? So can I take the other model? Right. So the writing part of the question is clear. So we are going to find the equation of the plane passing through the line of intersection of x plus y plus z minus 1 equal to 0, and that is equal to 2x plus 3y minus z plus 4 equal to 0, or this. So we can make use of single zero while writing two plane equations. So here we can understand that these two plane equations are intersecting. Apart from indicating two zeros, we can use 1 0 for convenience in the notation. And the task is which are parallel to coordinate axis. So what was the question tag here? We need to find the equation of the planes passing through the line of intersection of these two planes, and that plane is parallel to the coordinate axis. Clear to everyone? Question tag. So let us apply the formula pi 1 plus lambda pi 2 equal to 0 as usual. So you take the values as common here. This is our new plane. Now we are assuming that this plane is parallel to the coordinate axis. So here we are obtaining three plane equations. So if you assume that the above plane is parallel to x-axis, you will get one type of lambda. You assume that the plane is parallel to y-axis, you will get another lambda. Like that, we are going to determine three lambda values here. Okay. Now let us visualize this. This is our required plane. And it is given that this plane is parallel to x-axis. Now from this, what we can say? This is our required plane and it is parallel to x-axis. So from this, what we can say? How do we determine the value of lambda here? So here we need to understand that x-axis drs are 1, 0, 0. That is correct. And the coefficients here are nothing but drs of normal of the required plane. So here, if you draw normal to the plane, this is perpendicular to x-axis. So we are going to apply perpendicularity condition here. A1, A2 plus B1, B2 plus C1, C2 equal to 0. Any questions from anybody? So if you apply the condition that, so 1 plus 2 lambda into 1 plus 1 plus 3 lambda into 0 plus 1 minus lambda into 0 equal to 0. A1, A2 plus B1, B2 plus C1, C2 equal to 0. So from this 1 plus 2 lambda equal to 0, which gives that lambda is equal to minus 1 by 2. So whenever a plane is parallel to a line, always understand that the normal of the plane is perpendicular to the line. Okay. So always make use of the perpendicularity condition. So whenever a plane is parallel to another plane, in such cases the ratio of drs are parallel, equal. So here, what are the drs of x-axis? It is nothing but 1, 0, 0. Please understand, direction ratios are infinite in number. Agreed? Direction ratios are infinite in number. So you can take 1, 0, 0, 2, 0, 0, 3, 0, 0, anything you can take. But the value is fixed. So even though if you take 3, 0, 0, now say 1 plus 2 lambda into 3 is equal to 0, always this thing gets cancelled. you will get lambda is equal to minus 1 by 2 as it is. Accepted? That's it. That's why the impact of 100, 200 doesn't matter. So by default we take the standard unit vectors, say 100 for x-axis, 010 for y-axis, and 001 for z-axis, which gives the computational convenience. So we make use of them always. Okay. Now, yes, please ask your doubt. Yes, it is right to say a plane is parallel to a line. So, again, you fix that. This is a plank. This is a fixed rod. So, rod acts as a normal to the plane. Now, if you hold this and you put it on any bar, so that these two are parallel, this rod is perpendicular to this line. Agreed? The type of stand we will see in physics lab experiments say one iron rod is attached to a wooden plank. The plank is nothing but a plane. The rod is nothing but normal to the plane. So if you hold that and place it on any line or any rod, so you can say the plane is parallel to that line. So the normal always perpendicular to that line. Yeah. So please understand, if plane is perpendicular to another plane, always we use perpendicularity condition. If plane is parallel to a line, then also we use perpendicularity condition. If plane is parallel to another plane, there we use the parallel condition. A1 by A2, B1 by B2, C1 by C2 equal, right? You can visualize that. So for that visualization, you say you take another wooden plank, you fix a rod to it. Now see, these two planks are placed side by side, so they are parallel, hence the rods also parallel. Okay? Is that visualization correct? That's it. So any more queries from anybody? Thanks to all. So similarly, so if you substitute lambda is equal to minus 1 by 2 at this position, you will get the equation of the plane as y minus 3z plus 6 equal to 0. So that is one plane equation. Now again, let us assume that our required plane is parallel to y-axis. So you have taken y-axis, its drs are nothing but 0, 1, 0. Again, if you apply the perpendicularity condition, you will get the lambda value as minus 1 by 3. So substituting the value of lambda here, I will say you are going to get the equation as x plus 4z minus 7 equal to 0. Similarly, if you take z-axis, you will get lambda is equal to 1, so that the respective equation you will get it as 3x plus 4y plus 3 is equal to 0. I think calculating the individual lambda values is not necessary because you understood the concept how to do. So any more queries from anybody, please say. Are you clear with this model, please? Now I just want to introduce the small concept. Then let us close our today's session there. And tomorrow we will meet with the problems based on that concept. So we will conclude the concept of planes tomorrow. And obviously I want to take some of the previous year questions. And depending upon your understanding, I will take more number of examples and the difficulty level as you require. Otherwise, we will conclude our discussion of planes tomorrow itself as per your requirement. Please understand, number of classes is not at all a constraint. We will consider the level of understanding. That's it. So we discuss about angular bisectors. Now, let us take that there are two planes which are intersecting. You can take any kind of thing. Now what happens here, at this intersection you will have an angle theta. So whenever two planes intersect, if you take one angle is theta, the other will be always 180 minus theta. So we are going to get a new plane equation which has the property that it bisects the angle. So if the angle between the two planes is 60 degrees, so you are getting a new plane in such a way that it makes the angle 60 as 30 and 30. So for a simple visualization, say this is our first plane and this is our second plane. If you say this is theta, you are going to obtain a new plane equation which bisects this angle. So if you say the total angle is 60 degrees, so this angle is 30 and this angle is 30, it is bifurcating in such a manner. So if you say this is plane 1 and this is plane 2, the new plane, say pi, bisects the angle in two equal halves, 30 and 30, depending upon the angle. If it is 90, 45 and 45, it will does like that. So if we calculate the angle between pi 1 and pi, it is exactly half of the angle between these two. Okay? Clear to everyone? Right. Now the formula for the calculation is, let us say the first plane is a1x plus b1y plus c1z plus d1, and the second plane is a2x plus b2y plus c2z plus d2. Now, since we are having two angles between the planes, we will get two angular bisectors. One plane bisects the acute angle, the other plane bisects the obtuse angle. So, the formula for that is a1x plus b1y plus c1z plus d1 by square root of a1 square plus b1 square plus c1 square equals to plus or minus a2x plus b2y plus c2z plus d2 by square root of a2 square plus b2 square plus c2 square. This formula is very similar in the two-dimensional geometry you have studied at the +2 level. There the third coordinate is missed rest of the thing is very same. So there we calculate the angular bisectors between the two lines. Here we calculate the angular bisectors between the two planes. That is the only thing. So while using plus sign on the RHS, you will get one plane equation. While using minus sign on the RHS, you will get another plane equation. Okay? Clear to all? Please take a note of this formula. Now understand that we apply this formula whenever the product of the constants is positive. That means after observing the given plane equations, we will write them in such a way, if required, such that both constants have same symbols. Either both are positive or both are negative, the constant values. So that if you multiply them, d1, d2 will be positive. Clear? So by rewriting the given equations in that way, then only we apply this formula. This is most important. So while applying plus and minus sign, obviously you will get two distinct planes. That is okay. Now the thing is how to determine which plane bisects acute angle and which plane bisects obtuse angle. That we need to know. d1 dot d2 greater than 0, the product. Please understand, if both constants are positive, then product is positive. If both constants are negative, then also product is positive, right? So by rewriting in such a manner, we will apply the formula. And the origin will lie on one of the planes, because you are finding two bisecting planes. Origin will belong to one of the sides. So please understand, whenever we use plus symbol on the RHS, always it will give the plane containing the origin side. In other words, it bisects the angle which is on the origin side. Please take a note of it. While using plus sign on the RHS, whatever the plane equation we obtain, that always gives the bisecting plane which bisects an angle which is on the origin side. Okay? Clear? Please let me know. Are you clear? Have you noted the point? Right. Another thing is, if you want to know origin lies on what side, is it lying on acute angle side or is it lying on obtuse angle side? For that it is very simple. We simply calculate a1 a2 plus b1 b2 plus c1 c2. If the value is negative, origin lies on acute angle side. If the value is positive, origin lies on obtuse angle side. Fine. If the value is positive, origin lies on obtuse angle. If the value is negative, origin lies on the acute angle side. Clear? So at this point, I want to stop our today's discussion. We will meet tomorrow with further continuation. So thanks to all. If you want to add something, you can add.